Everyone see my screen? Awesome.
Yes.
Yeah, we're Databots. So people call us a company, but we try to break outside of the confines of even what a company would be. We started as a hackathon team, just freely hacking, coming up with things. And we kind of mostly think of ourselves as a band, like a futuristic band with a black metal logo. Add us on Twitter. We post a lot, and our YouTube channel is where most of our content goes. And if you have questions after or just want to chit chat, totally DM us on Twitter. We're really interested in building our community. Here's us, me and Zach. We met at Berkeley College as interns. Zach had learned music technology and I had learned computer science. We did a skill swap and then we became a team. We do 80% music, 20% research. You'll find out what that means. It means we go on tour sometimes. And we play in front of audiences, well, in our minds. And we make AI death metal, eliminating humans from music. The focus of our research is neural audio synthesis. This is generating audio waveforms at the sub-millisecond scale. I think this is probably the most technical group that we've gotten a chance to talk to. So less explaining is necessary, but just in case, this is what audio looks like. And you can build machine learning predictors that predict a sequence of amplitudes like this. And these are the kinds of things we play with. So our very first experiment, we loaded a very large GRU multi-tier model. We trained it on Kurt Cobain acapellas. And at first we thought our first audio results would be noise or silence, or maybe there's some bug in the code. But actually it started screaming about Jesus. Oh my God, this moment, we played this, we looked at each other, we're like, what the heck? Should we even be doing this? Is this ethical? Are we like bringing back the soul of Kurt Cobain from the dead? Is this like a witchy seance? It felt uncomfortable. And so that meant that it's good art and that we had to keep exploring this. We started with a Theano project called Sample RNN, which was a Mila project. And originally the focus of it was speech synthesis. And later this spun off into like a speech synthesis company called Lyrebird. But we took their open source code and their model originally looked like this, and we turned it into this, made it 3 times bigger, switched out the GRUs for LSTMs, which worked better, added all these skip connections, which worked a lot better, and crucially, like changed the way the normalization was working. Originally, the code was producing a lot of DC offsets because it was normalizing each like 8-second chunk of audio between its minimum and maximum amplitudes. But of course, if you treat audio like that, then you're not respecting like the 0 point. So when you generate, you get a lot of DC offsets where the 0 amplitude could be not 0 valued, or where you want the 0 to be is not at 0. So it turns out if you just even remove normalization, it works a lot better. So then it's it's memorizing the audio more instead of generalizing. And I can see why the researchers are like originally wanted to approach this as like a generalization problem. But here, when like imitating the sound of a singer or a band, actually we do want some memorization, particularly at the small sequence scale. We wanted to memorize small patterns of timbres, but then combine them in unique ways. And so the way the sample RNN model works, it's like a, I call it a bottom up learning, where, it's learning, just the next sample. And it's the longer and longer you train it, the more it's going to learn like longer sequences of samples, and it's like expands outward. So when you hear a model trained, and I'll show you in a moment, when we train it on the Beatles, in the first epics, it's all texture, and then eventually you start hearing the instruments, and then some semblance of rhythm, and depending on the data set, like full music. So bottom up training, and the generalization you get is from early stopping. So you want to memorize the short sequences, but then have these long sequences be random, and then you can make these like deep fake models that sound like a band but are generating new riffs. And we released this research at NIPS in 2017 on generating black metal and math rock, which these two genres worked really well with our data set. We tried lots of things: electronic music, hip hop, reggae, anything that required 4/4 or just like range of timbre didn't really work so well as something like black metal, where the tempo is fast, the range of timbre is very, very narrow. I mean, it's like distorted, the same instruments, the whole album, the same production, the whole album. This reduces the range of short audio sequences that it needs to memorize, which worked better for musically. And instead of releasing our results like this, maybe like a typical audio research project, release it like this, we just released it on Bandcamp because we want to get a little more creative with it. So here's the deep the Beatles example. So we're training it on 30 Beatles hits, and at first it sounds very noisy. And then after a couple of days of training, yeah, so you can hear all the instruments in there. You can kind of hear Lennon, McCartney, timbre of their voice. You can hear drums, bass, all the instruments are there, and it's this wonky kind of drunk walk through it, which is fascinating. But before this kind of this effect you couldn't really achieve even with concatenative synthesis, or granular synthesis, which sounded very choppy and glitchy, good for making glitchy music, but not really for this organic live acoustic instrument thing. Which here, this neural synthesis approach, which has a bit of like overfitting on the small scale, gives us these smooth kind of drunk walk things. And just depending on the kind of data set that you use, it actually can make really enjoyable music. So since we released this on Bandcamp, critics started rating it and judging it, which we thought was hilarious. Like these are just experimental results, and what we got like a rating, obviously not a very good rating, but we were impressed anyone was rating it. The next album that we released was our black metal results, and that got slightly better ratings. When one critic said, what saved this album when compared to the other releases is that there seems to have been an actual attempt to present the material in as enjoyable a context as possible. What I mean by this is that Coditany of Timeness is actually structured like a real music release. We're like, all right, if people are actually listening to this, we should treat them like music releases. Let's curate the experience for the listener. which led to good results. So the internet's busiest music nerd, the Needle Drop, reviewed the black metal album. He's going to talk about it and play it in his video. Here it is.
Through a little metal album off of their Bandcamp, where apparently this record over here that is next to me is the computer trying to reimagine or reapply sounds that it gained off of Krallis's Diotima, which, if you're familiar with math rock and black metal, is a very large, epic, washy, loud, and atmospheric black metal album. So as I play a little bit of what I'm going to play right here, you guys are actually going to be hearing the raw audio in the mix of this video here. So let's go, let's do it. Oh, that's really weird. It makes me smile because I'm actually kind of amazed by it. It obviously doesn't sound like much and is not that inspiring from a compositional standpoint, but the aesthetic is there. I mean, it's not perfectly clean and well assembled and smoothed out like the way that Krallis's sound is, but to me it sounds like I'm honestly listening to a live demo of Krallis. There's
passes the black metal Turing test. So when we had put this out, we didn't actually ask the band if we like permission or anything. You know, better ask forgiveness than permission. So we tried asking forgiveness. We're like, we each emailed them like, hi, we trained a neural network on raw audio of your album. We used it to generate this other album. Let us know if you want us to do a takedown or if we're misrepresenting your art. Obviously, this was one of our favorite bands. We respect them a lot. And they responded immediately. They're like, hey, whoa, that's awesome. I don't personally feel misrepresented at all, but thanks for asking. I'll think about some collaborative ideas. Cool. So this blew our minds. This was a band that Zach and I had been listening to for a decade, and now we were talking to them, and now they want to collaborate with us. It's incredible. The creative lunacy continued. So we did collaborate with them, with their other side project, and we made this 10-hour version of their record as part of their album release promo. To 10 hours of textures from an improvisational grindcore band. It was a hit. And it works really well for bands like Meshuggah. Like, this really captures the tone of Meshuggah's album, Nothing. And Meshuggah is known for being very mathy. Here, you know, it's this wonky, drunken walk kind of rhythm, which is a fascinating approach, reimagining their sound. What Sample RNN became was just this machine that could just produce albums, and like reimagining all our favorite bands. It was just such a delight. And a community started like forming around our channel. Here, one of our fans made this a parody video of our NoFX album, which is a skate punk genre. They spliced a live video of NoFX playing to our generated song, and of course, this model isn't smart enough to sing English or know about English. It's just generating nonsense syllables, but it's fun to imagine what could those lyrics be. Love it. You can also pair this with lyric generator. I mean, obviously it's not generating the lyrics, it's not a lyric audio model, but you can pretend. And here we made a 10-hour Cannibal Corpse video with generated Cannibal Corpse lyrics. And the lyrics trigger whenever it hears the vocals. So we use a source separation model, which, even though it's never seen death metal lyrics, it'll still separate death metal vocals, which is really nice. This one was a WaveUNet. And yeah, that means use a volume trigger. And then whenever the singer is singing, words on the screen. And here we fine-tune GPT-2 on the Cannibal Corpse lyrics. Fine-tuning GPT-2 is a really good way to make lyrics. And GPT has been trained on, Reddit, and so it has a lot of political rhetoric in there. If you're not careful, your model will just decay into politics. So we had to manually remove all of that out and just keep the murder and gore for your entertainment. Very brutal, very brutal. And eventually we figured out how to like design the data set in such a way that everything that the neural net produced actually sounded good. The reality was only 10% of the content was usable, and we just went in through and manually curate what sounded good. But here we found we perfected kind of the data set. We did this like with an augmentation trick by taking the left channel and the right channel and concatenating them into mono, and then doing inverse, flipping the phase and concatenating those. So we have, extending the data set 4x, and turns out mixing that with technical death metal, which is, the tempo is very fast. So the patterns of audio it needs to learn are actually shorter, so it's easier for it to learn. And we got Relentless Doppelganger. And this has been live streaming 24/7 since 2 Aprils ago. It celebrated its 2-year anniversary, and it's still going. Let's listen to it. every time I come back and listen to it, it does something new, or just like a new approach to its sound that I've never heard before. Here, because sample RNN doesn't have a real-time factor of 1 or less, we have to generate all of these samples in parallel. So we generate 100 in parallel. So every hour, 100 1-minute tracks get generated. We just stick those together and then put them in a buffer, and we live stream them with FFmpeg, and that's running on a Linux server. We just stream that directly to YouTube. And this is how you can make 24/7 live streams. And we're thinking about starting maybe an open source project around this, because it's kind of a really interesting technology. And once you get the community doing it, then we also have code for like how a Python script can read in a YouTube live stream. It's just pulling in M4A files like every 5 seconds or so. And so now imagine that you have these generative live streams listening to each other and jamming with each other, remixing each other in real time. Like, fascinating. This is gonna be really cool. And if anyone wants to help us with this, please add us on Twitter, reach out, or let me know in the comments right here in the Zoom. We definitely weirded out the band whose training data this was. Skynet is writing our next album, they said. And what we learned is that we can actually just cold email most bands and say, hey, we're weird AI computer hacker people that make music software. Do you want to collaborate? And it's easier to approach musicians as a computer scientist than it is as an actual musician. For example, we made this music video with the UK beatbox champion Reaps One. We train just a beatbox model, and he does a kind of battle with it. It's like a duet.
Enough for a piece of rosum. Let's listen. And for with VDM and this exploration just
And for Reaps One, his beatbox bot, he sees it as a like opponent design is what he calls it. It's something that pushes him to make his human craft better, and by using his own instrument. And in the years that he's listened to this generative content, it's made him come up with new rhythms and new patterns and new sounds that he's never made before. So we're entering into this world of deep fakes, and naturally the fans deep faked us. So we have fans in Ukraine that made this fake Databots strip mall somewhere in Ukraine. I don't know. I thought it was funny. So we made this deep fake of Frank Sinatra singing Britney Spears. So this is now using the Jukebox model. This is like when it first came out, we're like, okay, let's see what it can do. And here is what this sounds like.
You're taxi, I'm slipping under. datasets, and I love what you do. Don't you know that you're toxic?
So why this video is of interest is that it would trigger a takedown claim. It was our first experience dealing with this. YouTube took it down, and because this is such a new space and the legality is really unclear, and different countries have different laws. Can you train machine learning on copyrighted material? What are the limitations of that? We're still figuring it out as a society globally. So we got help from the EFF. They generally defend Creative Commons and internet freedoms. They helped us pro bono. And turns out that they have an argument for why this is fair use. And we stated our case to YouTube, and YouTube was like, oh, yep, actually, sorry, bad takedown. Let's put it back up and, give you shared ownership. So we brought back Frank Sinatra Toxic from the dead. And now the state of this video is that for the music licensing nerds out there, the publishing royalties go to the owners of the Britney Spears lyrics, and the recording royalties go to us now. And Frank Sinatra doesn't get anything. So this is really interesting. It's in the style of Frank Sinatra. It doesn't actually exactly sound like his voice. Actually, most people thought like, hey, no, you didn't. I know Old Blue Eyes. That's not Old Blue Eyes, but it's in the style of classical pop, and it's differentiated enough, and it's not pulling from any previously recorded content. So, this wasn't tested, in a court in front of a judge and a jury. Just YouTube and the labels kind of hashing it out. It is a very interesting outcome, and I feel very confident that this kind of outcome will keep showing up in the near future. So we had a lot of fun with Jukebox. We set up a 36 GPU cluster just to explore the hyperparameter space of it. And I'm sure everyone here knows about Jukebox, but it's a very large transformer based neural audio synthesis generator using VQ VAE. And it's very, very slow to generate, even slower to train. I think the original model had at least $1 million in like compute budget just to train it, but they give it for you pre-trained, and you can fine-tune train it. And we've been trying to make fusions. So beyond just deep fakes, beyond just, hey, let's make classical music, hey, let's make rock music. Like, can we I want to make music that's never existed before. Like, how do we do this? And Jukebox lets you combine genre vectors together and the artist vectors together, and they share this latent space that you can explore. And most of the time, the fusions don't really work that too well, but here mixing funk and deathcore and gent works really well. So here's a really good example. You hear the chugs of metal and like the of funk, and it actually works. Awesome. So Jukebox in many ways is kind of like the opposite of sample RNN. It's top-down generating. So it looks at a bird's eye point of view and generates a sequence first, then it upsamples it, then it upsamples it. And this allows it to stick to 4/4 music a lot easier. and but you know, it's slower to train this way. So yeah, there's trade-offs. I think this approach of like, you know, upsampling is really nice, and it allows you to, you know, make a style latent space at like the top layer, which is really nice to create these fusions. People could improve upon Jukebox for, like, you know, near future research is that the upsampling doesn't need to be transformer based. And Sandra Daleman had the whole like Twitter post like a few months ago about like the differences between likelihood losses and adversarial losses, and like where in the architecture do you want to put these things, and like where do you want mode seeking behavior and where do you want mode covering behavior. So for style and genre and like top level song structure, like you want it to cover your entire like, you know, the distribution of your data set. So there you want likelihood models. But then when you're at the low level, and you know, sample RNN shows us that actually like memorizing is at the short sequence, it actually, you know, works really well. Like here, like mode seeking is totally fine. And so like these upsamplers could be GANs. It doesn't, you know, they don't need to be likelihood models. You know, if they're being conditioned by likelihood models at the top layers. So I think this is how, like, the future neural audio synthesis models is what they're going to look like. And they're going to be faster to train too. Let's see. We have a residency where we bring in artists and we let them train stuff on our GPU. We featured Hector Sismos, artist from Mexico, and he trained Jukebox on 40 gigabytes of tribal music. And check it out. Awesome. You should definitely listen to it. So neural synthesis brings us into a whole new era of sampling. And you know, sampling has a history back to hip hop, and bands like groups like Public Enemy, they would sample hundreds of records on their hip hop albums. And they would do this until like the early 90s when they started getting in, like, where labels realized they could sue people for this. And then this whole art form disappeared. But however, with like neural synthesis, we can generate, you know, things that sound like classic funk music, but, you know, they don't sample any previously recorded recordings. So there's no label that's going to sue you for it. So what we did is release 24 hours of 12 hours of generated funk. We called it No Soul. We released it to public domain, and we made this like explorer for it. So here's all the full 12 hours. Let's listen to it in here. Select a chunk and download it. And we ran this entire data set through PEX. So the other half of Databots, Zach, he works at PEX. They're the #1 like fingerprinting service that all the labels use to find out like if anyone has like posted their content on YouTube without permission or whatever. And so we ran it through PEX, and there was no overfitting anywhere. So we feel confident that this data set will not trigger any copyright takedowns. And we collaborated with a hip hop producer to he used these samples to make a hip hop song called the Black Skin Machine. And it's really hard to find singers that can sing in that style, but now we have this sample data set. Let's see. In the interest of time, I'm gonna skip over a few things. Oh, do you guys know about the AI song contest? I hope many of you submitted something to it. And if you did, I'm like post a link to it. Definitely want to know who made which tracks. So last year we made this like death metal. We used like Vocaloid to make this death metal singer, and we got like 12 out of 12 points with the judges. So this year we're trying to get last place. So yeah, if you could everyone just vote not at all. You don't like it. Thank you. It's called Can't Play Any Instruments, and the reality, the sad reality of doing AI music, if you're a musician, is that like you stop practicing and you get really bad at playing your instruments. It's kind of sad, you know. We literally generated this in our sleep with like very little effort. We made this like interface where you just, okay, here's the genre that we want, here's the data set, give me 30 seconds or 90 seconds of it, fall asleep, wake up, it's done. This should not win. We should not be praised for this. And we got a whole we got Can't Play Instruments volume 1 through 4 coming out soon, all hardcore punk. It's great. We're actually going to transition to a live band. Mathcore Index Fest coming up next month. We got Mathcore live stream, Complexity Fest. I think maybe some of you guys know about this one in the Netherlands in February. We're gonna be there. And finally, want to just touch a little bit on this pre-published stuff for Izmir that we're doing with Pedro and others. So we made this data set of Guitar Pro files, like over 20,000 of them, and we converted them into this token format, which is readily usable with language models like Transformer. And here, so you can train Transformer and like sequence-based models that make Guitar Pro compositions. I'll just and it can get really crazy with just random, like no machine learning, just randomly generating the data set. So Pedro and others actually trained models on this data set to make some really good rock and metal stuff, and we're going to be releasing that soon. Yeah, this is an example of how we convert this format to that format. There's like over 1,200 hours of music in here. Some histograms. And anyway, in summary, the end is near. We are selling merch. Actually, I like this one. I'm wearing the red one. Red metalhead. We're Databots. Key takeaways for you guys. You don't have to just submit research the normal way. You can go outside the ivory tower and actually interact with the culture of music, and music nerds they're really, really interested in what's happening right now with AI. They really want to know what you guys are doing. And they want to see you release cool stuff. Trust me. Give it a shot. I know not everyone that goes into PhD research for like audio signal processing, like even thinks themselves as creative or has ever played an instrument, but that's okay. Like try it. And I don't know, let's build a community together. And you can cold email your favorite musicians and artists and work with them. And you reach out, hey, I do AI. They're gonna want to work with you. Okay, I'm done. And now it's Q&A time. Thank you very much.